Hello, and welcome to Putting Next Generation Sequencing in Motion with Globus Genomics and EMC Isilon, sponsored by EMC Isilon. I'm Rebecca Friend, and I'll be moderating this webinar. Our speakers today are Ravi Maduri, Patrick Combs, and Sasha Pagel. You can read their full bios on the right side of your window. Just a few technical notes before we begin. If you have trouble reading a slide, please hold and drag the right corner of the slide window to enlarge. Please also disable your pop-up blocker to participate in the interactive parts of the presentation. We will follow the presentation with a Q&A session. Please submit your questions during or after the presentation using the Q&A box at the right side of your window. Okay, I think we're ready to begin. Sasha, take it away.
All right, just a sec here. All right. Hello, everybody. This is Sasha Pagel from EMC Isilon. I'm the Business Development Manager for the Life Sciences vertical here at Isilon. And I'm excited to have two guests, Patrick Combs and Ravi from Globus Genomics, to share what we've been doing in terms of bringing our two technologies together. So the real question, just stepping back real quickly here, is why even bother bringing our Isilon technology and Globus Genomics technologies together? And ultimately, it really comes back to making an impact in terms of healthcare and moving biological discovery forward. And really, at the end of the day, especially if you look at the application of next-gen sequencing in the last, say, 24 months, the rate at which it's being developed and applied in the clinical and healthcare setting is just astounding, especially when you compare it back to, say, the early 2000s and the use of analog gene expression. So there's huge promise, and there's already being demonstrated impact today in the market about this using this technology. However, there are still challenges before us, and this ranges from just a huge influx of data from a variety of different sequencing technologies. Really, how do you store it? How do you manage it? How do you move it? Moving that data, making it accessible to computing resources, to the actual analysis and interpretation. What's the provenance of that data? How do you, repeat someone else's analysis or workflow? And in all that is also in terms of reproducibility, and how do you do that repeatedly, say, in a very controlled environment where you have to adhere to, say, certain policies and practices. So definitely there's a few challenges ahead of us, but there's definitely huge promise in terms of overcoming those challenges. And so I'm going to let Pat kind of take us a little bit further into that realm.
Hi. So thanks, Sasha. So in the life sciences, we have, and shown here, we've broken things up into a few different stages of how data flows, and we see tremendous advances in the last few years in the rate and quality of data as it's been acquired from different next-gen sequencing instruments and sources. And that has led to a real proliferation of data and growth in data repositories on site at different sites, to the point where we're seeing a lot in the field of an inability of people having difficulty organizing all of this data and helping it sort of move through the rest of the stages from analysis to archive. And one of the big challenges that we're experiencing, or people are experiencing right now, is the ability to analyze that data quickly and effectively, and then do that in a reproducible manner such that they can set up a sustained pipeline for the processing of that data. And so we just see, an incredible amount of growth there. So one of the challenges that poses is that when you have all this blockage of or large growth of data in a repository that you can't analyze, is that whatever systems you have currently for doing that kind of analysis are dedicated to trying to relieve that backlog and move things through. And that doesn't leave much other time to do any other new novel work within the life sciences to develop new pipelines or reproduce other workflows that are found from other sources. So reproducing workflows becomes an extreme challenge. If you find something from another site or another publication or paper that seems interesting and it's something you want to implement or at least experiment or play with on site, it's something you can't really do because your current compute resources are dedicated to trying to relieve that backlog of data. And the same problem occurs when you're trying to develop new workflows. And they both have the same challenges, essentially, is that you have limited compute resources available on site, and the ability to play around or customize things between stages is extremely time consuming, so that you all the time that you spend doing that is time that you cannot spend relieving the backlog of data that you have. So with that in mind, what we have been looking toward are other solutions out there that will help you model these new pipelines, and workflows, and develop new workflows so that you can potentially implement them in your regular workflow on site or even within the cloud or something like that to help you relieve this backlog of data. And one of the coolest and newest products we've seen for doing that is through Globus Genomics. And Globus Genomics is providing a fantastic service here to help people model and develop new workflows and then potentially implement them in a production way on site. So with that, I'll hand it over to Ravi to explain the function of Globus Genomics and all of its ins and outs.
Hey, thanks, Patrick, and thank you, Sasha, for setting it up. As my name is Ravi Maduri, I'm a product manager for Globus Genomics, and I'm a fellow at the University of Chicago in the Computation Institute, and I'm saying it mostly to kind of set the background on how we came about building Globus Genomics. As a research group working in big data management and providing useful tools and services to make big data management easier, we have been working with various domains of science for quite some time. We started working with high energy physics and climate modeling people, the domains that are traditionally known as our traditionally big data sciences, and in the past few years, with the lowering of the cost of the sequencing data, generating of sequencing data, we've seen genomics get into the big data domain, and it is getting into big data domain quite rapidly. And again, one of the things that we realized when we looked at genomics as a field is essentially that the need for better tools or services that could allow users and researchers manage their data more effectively is becoming a much bigger and a problem that is gaining in complexity and hurting productivity quite quick, at a much quicker rate than it has been in other domains. And when we looked at genomics as a domain, we've essentially found two areas of issues or problems, and we thought these are great opportunities for us to create a product called Globus Genomics to address these problems that we're seeing. One set of the problems are in the area of managing data. As Patrick and Sasha put it really well, the instruments have been generating data at much faster rate than ever. But as you can see in the slide, we tried to kind of capture this in a small graphic. As a researcher or as an end user, as a researcher who is doing analysis on next-gen sequencing data, you have data sets across multiple locations that are geographically distributed. You have your local Isilon clusters where you have a lot of raw data that your machines have generated. you probably have collaborators that are in other institutions that have data sets that you would want to access. You also have things like 1,000 genomes data, HapMap, and 1,000,000 genome data. They're all publicly available data sources that you would want to compare your analysis with. So you have other data sets that you would want to secure or that you would want to use in your own particular analysis. So as you can see, these are all geographically distributed, and they're all connected to your institution in different ways. For example, sequencing centers like Illumina and Complete Genomics and other institutions typically send you a bunch of hard drives. They'll use FedEx to ship them to your institution, and then you have to go through the process of loading them up into your local Isilon cluster data storage element. And your collaborators may have set up FTP and SCP and other servers so that you could access their data sets, download them using the internet in very ineffective ways, because FTP and SCP were designed for a network that is at least a decade old, and they're not these protocols are not suitable to address the advances or to take advantage of the most powerful networks that we have in place today. And when we look at so this slide looks a little bit weird so we try to, in Globus Genomics, we address the problem of just moving data, large amounts of data from your remote sequencing centers to your local Isilon clusters or to your local compute elements very reliably and easily using a service called Globus Online, which is based on a protocol that we created at the University of Chicago called GridFTP, which is a high-performance TCP-based protocol that provides enough capabilities to take advantages of the advances in the networks that happened recently. And also, Globus Online provides a sort of a high-performance, reliable service on top of the GridFTP protocol. So end users, such as yourself or researchers, can move data from wherever it is generated to wherever it needs to be using this service that provides a sort of a nice Web 2.0 interface which makes it easy for you to move data from one place to another. In addition to being secure and fault tolerant, Globus Online frees end users from not babysitting their transfers anymore. So they can, say for example, Illumina generated maybe a few terabytes of data for you that you would want to transfer to your local Isilon cluster. You could go to Globus Online and select the Illumina endpoint and select the local Isilon endpoint that you have and say transfer these 4 terabytes. And Globus Online will take care of all the retrials and make sure that the data is securely transferred. It performs checksums so that you're sure that the data has been completely transferred, and it does it using security, end-to-end security, so you can be assured of that nobody is tampering with the data transfer. So with Globus Online, we feel like we've addressed the data management side of the genomics data, and we coupled the data transfer aspect with the analysis aspect by using a tool called Galaxy, which is a web-based framework that allows users to interactively create workflows by using a Web 2.0 interface that is both dynamic, and it also allows for users to set the parameters that they want to set on the individual tools and analyze the data on using the Galaxy workbench. Galaxy provides in addition to being able to interactively run this analysis on various using various tools, you could also build pipelines that would go through a set of series of analysis, and you could automate the whole end-to-end workflow. And the way you could automate is that you could use Globus Online integrated into Globus Genomics tools to get data from various remote locations. This could be your sequencing centers, your Amazon S3 locations, or it could be your local Isilon clusters, and get the raw data moved into Globus Genomics, into Galaxy, and run the analysis pipelines at scale using the Amazon infrastructure, and put the data back where it needs to be, put the process data that results from the running various analysis back where it needs to be. So in essence, we kind of try to address the end-to-end problem, and we feel like the Globus Genomics solution provides a really good solution for end-to-end analysis of next-gen sequencing data, using a combination of Globus Online for reliable data movement, Galaxy to create and execute workflows, and Amazon EC2 infrastructure to provide the scale so that you can scale on demand and elastically. So with Globus Genomics, we feel like we have an integrated product that provides an end-to-end capabilities where you could define workflows that Patrick and Sasha were talking about. These workflows could be a new workflow that you're designing you're creating a new hypothesis or you're validating it. Or this could be state-of-art workflows that are already defined and they're already very well debugged and understood. And because we integrated moving data using Globus Online, you could get large amounts of data analyzed very quickly using Globus Genomics. And the resources were all sort of provisioned using the Amazon infrastructure, so you only pay for what you use, and it's very elastic in nature. The additional capabilities that we understand that as a service provider in Globus Genomics, that it's not just enough to provide something and leave users to figure it out. We actually provide a professionally managed platform, and that we work with you in terms of getting data moved from your Isilon clusters or your S3 buckets, and we provide some best practices pipelines. And we have a lot of analysis tools that we make available in this workbench. At the last count, we have close to 700 analysis tools that provides various capabilities in next-gen sequencing data. And then a lot of endpoints are pre-integrated, so you could, like Broad Institute, if you're getting data from PerkinElmer or other sequencing centers, we could get the data automatically moved from those centers into the analysis platform and have them go through these best practices pipelines. And with Globus Genomics, since we are academic nonprofit, our subscription plans for using Globus Genomics are mainly geared towards being sustainable and being able to sustain our team that provides a service to researchers. So with that, I would like to kind of illustrate two collaborations where these collaborators have been using Globus Genomics quite successfully over the past 1 year, and we have quite a few of them, but we just wanted to highlight two here just to showcase the differences in these two engagements. Bill Dobbins is a researcher in University of Washington in Seattle, and his group is doing research in neurodevelopmental disorders, and they have a lot of collaborations across the country, and they get data from various collaborators and also from PerkinElmer, and they've been doing their analysis using shell scripts and mostly manually, and in some sense he was kind of making his postdocs become computer science hackers, in addition to being a computational biologist already. So they've been using Globus Genomics, and they were able to achieve 10 times more speed up on the turnaround time for the results of the analysis. And they're one of our happy customers, and they've been able to kind of reduce the time to science quite a bit by leveraging Globus Genomics to use their analysis to run their analysis. And the other example I wanted to kind of illustrate is Dr. Nancy Cox from University of Chicago. Dr. Nancy Cox is a leader in pushing the envelope on doing cutting-edge next-gen sequencing analysis. And with that group, we've been pushing the boundaries on creating a computationally efficient genotyping pipelines. In addition to just creating one genotyping pipeline using GATK, we have created 4 pipelines using various open source tools, and we created a workflow that would call consensus on genotyping results from these various computational algorithms. And this work has been going really well, and our goal is to, once we have this consensus caller pipeline that uses GATK, Atlas, Freebase, and Haplotype Tooler, we want to make this available for all the users of Globus Genomics platform. And in all these cases, these pipelines automatically move data from their local deployments or local storage elements into Amazon to get the analysis done at scale. So with that, I would like to give control back to Pat.
Thanks, Ravi. That was fantastic. What we wanted to just go over is just how Isilon storage is used commonly in the life sciences. And for those of you who aren't familiar right now, Isilon is a scalable NAS. We can scale up to 20-something petabytes right now, and more later. And we run a clustered file system called OneFS, where each node can see the same view of the file system and is able to serve for any other aspect of the file system on any other node. And Isilon also provides a number of add-on software packages that enhance the functionality of the platform. We have things such as Smart Connect, which provide connection balancing across a cluster of nodes. We have other items such as quota support and analytics support and things like that. In general, within the life sciences, we provide a fantastic platform for quick multi-protocol access for all kinds of things. We are commonly used to receive data from instrumentation. We can do it for support a wide array of instrument and instrument data. We provide good home directories for users and scratch area for users as they're developing new workflows and analysis methods and things. We are also a good platform for providing data to cloud-based analysis platforms such as Globus Genomics. We also, for intensive high-performance compute environments, we can serve as Tier 1 or Tier 2 storage for these types of environments, and also provide integrated HDFS protocol access for Hadoop. And what we're looking toward here is that Isilon in the life sciences and working together with Globus Online, will help relieve some of the analysis bottleneck that we see. In general, essentially, instruments are always going to produce data faster than it can be analyzed. And we only grow our storage environments for Isilon, and we only grow our analysis environments if we expand into new platforms for performing this kind of analysis and move data through faster. And shown here is just a quick graphic meant to describe how data is meant to flow through a system that uses a EMC Isilon cluster on site and Globus Genomics to do a significant amount of its analysis. And going forward and working together with Globus Genomics will provide you a platform to perform a lot of analysis without any disruptions to your existing analysis. We imagine that most of our customers have Isilon clusters on site, gathering data from their various instruments, having it build up within the repositories that they have on these Isilon clusters, and no way to model new analysis and no real effective way to model new analysis without disrupting their existing workflow or anything, making changes to their production environment. So Globus Genomics provides a platform for you to do that kind of work and then potentially bring it back into your production environment as soon as it's ready. You're able to rebalance the flow of data, hopefully removing that analysis backlog by developing new methods and things that will help you move things through faster and model new pipelines and workflows before they go into production. And then essentially, with Globus Online and Globus Genomics, if you're collaborating with someone who also uses the same platform, you can meet in the middle to collaborate. You don't necessarily have to transfer large volumes of data around, which is time-consuming and space-consuming for everyone, but instead meet in the cloud and then just transmit down the resultant analysis, the analysis results from that collaboration back to your local Isilon cluster. And don't worry about moving the incredible volumes of data around like we used to. And I think that's about. And thank you. Yeah. And so, Sasha, did you have any final words for this?
So no, thank you, everybody. This was a great overview highlighting how Globus Genomics and Isilon is meant to relieve the bottleneck in terms of the analysis of next-gen sequencing data. And so we have a little bit of time for some questions from the audience.
Okay, great. Yeah, we can jump in here and move on to Q&A. So I think our first question that we have for the speakers is coming up on the slide area now. Can you operate Globus Genomics in a hybrid cloud environment today?
No, not today. We are using Amazon, various services that Amazon provides quite a bit in our solution. But we do have plans on figuring out how we could be using a hybrid cloud to some extent, be a little bit agnostic about what underlying infrastructure provider could be. But today, we use Amazon.
All right, great. So let's see, the next question we have, how does Globus Online compare to Aspera?
Right, so let me take this. So Globus Online provides sort of we're not point-to-point capability like Aspera. So Globus Online is really a service that users can use to move data between multiple Globus Online endpoints. We do, from a technology perspective, the differences are that we use GridFTP in Globus Online, and Aspera uses a sort of a commercial closed FASP protocol. And to some extent, that's the performance-wise, we do compare reasonably well with respect to performance with Aspera, even though there are different protocols that are being used. Our goal in Globus Online has been to kind of not only just worry about the transfer or getting performance out of your network, but also higher order functionality to make sharing of data easy and secure, to create groups that allow that have access to the data to use group-based authorization capability. So we're sort of looking at a higher order service elements that will make the user experience and the solution better.
All right, great. One more question here. When targeting the volume and layout of data and metadata loads seen in genomics, do you see a need for certain types of Isilon nodes or configurations at your clients?
Yeah, I can take this. The quick answer would be yes, and the longer answer would be that it's somewhat dependent on the volume of data that's being moved through and the type of compute environment available on site. And typically what we recommend is that our X series is a good balance of things between providing enough storage to do a lot of this work and performance for a lot of this work. But then we can also use our NL series for retaining the incredible volumes of data that people have in a nearline archive sort of way, so that they can still access it quickly if need be. And then for client configurations, we do have some recommendations around NFS tuning and things like that. Again, somewhat dependent on the size and configuration of the compute environment available, but in general, they're pretty common to do a lot of NFS-based compute environments.
Okay, great. I think we've got time for about one or two more questions. Do you have any plans to offer alternatives to Galaxy, perhaps commercial options?
I don't know the question. I mean, I don't understand. So, any other options to Galaxy as a workflow tool, or?
We can move on to another one if that's easier. Let's see. How about, does Globus Online integrate with SyncIQ?
I can take this. I can take this, Ravi, or if you.
Yeah, go ahead.
Currently,
go ahead.
not currently. SyncIQ is our product for doing cross-cluster synchronization, sort of, and not currently, but perhaps in the future we will offer tighter integration along those lines.
Okay, great. And we'll do one last question here. What is the difference between Globus Genomics and CloudMan?
So, I mean, CloudMan provides a framework that allows users to launch Galaxy on Amazon. Our focus, I mean, even using CloudMan, you do require a fair amount of knowledge of how Amazon works, and you would want to plan it out quite in advance so that you don't get any surprises in Amazon builds. Our goal with Globus Genomics is to make it really easy for researchers not to spend any time becoming IT experts. Our goal is to make a Globus Genomics as a managed platform and make it available as a service, so researchers can focus on science rather than the IT aspects of the science itself. So the short answer is that Globus Genomics provides sort of a service-based offering to the functionality that CloudMan provides.
All right, great. I think that was our final question. We had a lot of great questions today, and we couldn't get to them all, but we'll be getting back to everyone who submitted personally after the webinar. Thank you for attending this Fierce Live webinar and for submitting so many great questions. I'd like to thank our speakers for participating and EMC Isilon for sponsoring today's webinar. This webinar has been recorded. You'll be able to access the recording within 24 hours on the same page that you used to register for the event. Thank you again for joining us, and we look forward to seeing you at future events.